My name is Eric Fung. I am visiting from up north, Toronto, Canada. I am currently a data scientist at a company called Shopify. We help merchants sell things online and in store. But I was an Android developer for almost 5 years at Shopify and another 3 before that. So this talk for me is exciting because it combines sort of the intersection of those 2 areas. I'm excited about it because it's an exciting time in the field of machine learning and mobile. Who uses Google Translate when they travel? Who searches your Google Photos without even having to tag them? Google can find your dogs. Or when you get a message, Google is now suggesting replies for you. All of these things are powered by machine learning. And not only are they available in Google's apps, but they're now available for you to use in your apps. So I've been playing around with ML Kit for a couple of months. I have some learnings that I want to share and to sort of inspire you to take a look if you've been interested in that for your own projects. OK, anybody recognize this? Anybody live in Hyde Park? Yesterday was my first time to Hyde Park and came upon this fine establishment. It's a Chinese restaurant. They sell dim sum. If you've never had dim sum before, it's little small bite-sized pieces of food that are served in bamboo steamers or sometimes just on plates. Not only are they steamed, some of them are deep fried, some of them are stewed. Now, when you go to a dim sum restaurant, not this one, but when you go to some dim sum restaurants, they push around all the food on these carts. And there's usually these old grandmothers who are calling out contents of the baskets, usually in Chinese, maybe in English if you're lucky. And at some restaurants, there's dozens and dozens of them. It's hard to keep track if you don't know what they are. And I thought one day, inspired by that episode of Silicon Valley, what if there was an app you could use to help you distinguish what dumplings were what? That'd be pretty useful, I thought. And it's a great application of machine learning. This task is called image classification. So give it an image. Give you a likelihood of what kind of image it is. So I don't think any of you brought dumplings. I tweeted about it a couple weeks ago. If you had a favorite dumpling place. But I did. Not only did I go to Oriental Walk, I bought some dumplings here. So I'm just going to put them out. You got the best seat. You're a little bit late, but you got the best seat to see what's going on. But don't worry, I will cast it onto the screen above. Just let me set that up for a second. If you take small bites, yes. All right. Let's bring this up here so you can all see. How's that? OK. So what I did was I built an app using ML Kit. I retrained an existing image classification model on a whole bunch of different pictures of dumplings and fed the live camera images into it. So you'll see how that works. All right, smile, everybody. That's you. These are the dumplings. All right, so we're going to go in close here. What is that calling it? Oh, it's bumping back and forth because my hand's moving. But it's kind of bouncing back between haga, which is a shrimp dumpling, which is what this is. So it's that floating point value, that's a percentage of, it's 80% certain that's what it is. Let's move over here to this one. Definitely not barbecue pork bun, but it's kind of bouncing between that and the real thing, which is a CMI. So sometimes different angles will change it, depending on how you train your images. So let's move to this one. This one is one it's never seen before. It's kind of guessing around at what it could potentially be. And this is one it's definitely had, but it kind of looks like one of those wraps. But it's actually a spring roll. Let's try this one again from a different angle. Yeah, the thing is, I retrained it last night with a bunch of new images. And there's also a difference. A lot of my training images were of steamer baskets and not these takeout containers. But I did add some takeout containers, too. But anyway, you get the idea of what an app like this can do. OK, so before we talk about what ML Kit is, I want to go a little bit of history of how we got to this point, how we're able to build apps like this for mobile, what TensorFlow is, what TensorFlow Lite is, and then that leads us right up to ML Kit and its support for custom models. So TensorFlow was, or is, an open source numerical computation framework from Google for doing machine learning and other types of numerical tasks. It had its first release in November 2015. As part of the source code repository, there was a sample for Android. The sample wasn't quite ready to use out of the box. You needed to build your own interpreter. And for an Android developer, it was difficult because it didn't use the build tools that you're used to. It used something called Bazel, and you also needed to download the NDK, which is something I've never done because I've never built anything at that level. So it was a bit difficult to use. This is how a bit of what it looks like. If you're familiar with JNI, you recognize this. There was a natively compiled library. You bring it into your project in Java like that, and then you access these two methods through the native interface. An interpreter and machine language is the thing that consumes the model and then is able to run your input through it and then output the predictions. A little while later, the Java API started to shape up a bit. There was a lot of work wrapping the existing C++ library with a Java API. And then for Android, they released a stripped-down version of the API that just does inference. So inference, you can think of it as prediction, is just the part that takes an input, executes the model, and then produces the prediction at the end. It doesn't include training. So that would be, how do we actually make the model more precise, more accurate by feeding it a whole bunch of examples. So this API is fairly straightforward to use. You pass it the PB, that's a protobuf file, that's where your model lives, into the constructor, and you get back this inference interface. And then there's methods to feed the input data into the interpreter, execute the inference, and then get back the output. Now, to get this, Google started making it available through a nightly build. So you can just download that pre-built yourself. You don't have to go through all that trouble. By May, they did what a lot of Android developers were hoping for, which is just to publish it as a Maven artifact. So now you can use it just like any other Android library. And then a little bit later that year, Pete Warden, who works for Google as a lead on the TensorFlow for Mobile project, he released a free ebook, which you can still download. That's super useful. By the way, these slides all have clickable links. So if you can't keep up with copying URLs and things like that, I can make the slides available at the end of the talk. And then lots of stuff started happening in May or June of 2017 at I/O. So Google said that they were working on something called the Neural Networks API. This is a hardware-accelerated layer that will be available on a number of devices. Think of it as just a bridge between GPU or some sort of custom chip on your phone that can do neural network operations very quickly, and framework developers like the TensorFlow folks, so that they can write against a common API, and then when it's available, it will execute on hardware, and when not, it will fall back to software. The other big announcement was something called TensorFlow Lite, which was a reimagining of how to execute TensorFlow on mobile. So up to this point, you could run TensorFlow. There was that Java API. You could download those nightly builds. But TensorFlow Lite was designed from the ground up to be fast on mobile. So among the things that they did were to change the file format. Now it's optimized for speed, and also to be as small as possible so it could load quickly and keep your APK size down. There was a new converter to take your existing TensorFlow models and turn them into the Lite format. And it was positioned as the next generation of TensorFlow for mobile. So while the old TensorFlow for mobile is still supported for your production apps that are using it, TensorFlow Lite is the way forward, and that's what you should use for your new projects. The initial release of it is intentionally constrained. That's how they describe it, because they want the current use cases that they are targeting it for to work really well. And over time, they'll kind of expand the set of operations you can do with it. Now, that takes us up to this year's I/O, where Google announced Firebase ML Kit. So ML Kit is part of the Firebase suite of SDKs. And out of the box, it comes with what they call base APIs that do a number of tasks that we just talked about right at the very beginning. So being able to detect images, being able to detect faces, recognize text. And things that were previously part of separate APIs, like the mobile vision one to do barcode scanning, are now part of ML Kit for Firebase. One really interesting thing is that they support a hybrid local or cloud execution model. So what does that mean? You can bundle the SDK with your app, and even if it's offline, you can do face detection. Even if it's offline, you can do image classification. However, if you choose to, you can also execute those tasks against Google's cloud so that you get better results. For example, with image classification on the device, you might only be able to recognize 10,000 types of objects. But in the cloud, you get the full range of 50,000 or something that Google provides. Running it locally in your own apps is totally free. When you use the cloud one, there are costs associated with it, so you have to change the Firebase plan that you're using. And the last thing, which is sort of the focus of this talk, is custom models. So this is when some of these use cases don't exactly apply. You know you want to do something with machine learning that's not available in the base API. You can use your own custom model. Now, if you look at these tasks that come with the ML Kit, you'll notice that they're very biased towards image recognition tasks. All of those things are basically some type of image recognition, taking a camera or a static live feed or a static image and telling you something about them. Google has said, of course, they don't never promise anything about timelines, that they will expand the capabilities in ML Kit over time to include things to do like speech recognition or sort of text generation, things like that. OK, so let's talk about how do you use custom models. So custom models, you have to, it's a bring your own model model. You need to get a TensorFlow Lite format model and give it to ML Kit. It has nothing to do with creating that model yourself. So you either can download one that you find online, or if you have data scientists that can work with you, you can kind of retrain an existing model or even write one from scratch. It provides a common API, a single API to run inference on any kind of model. So every machine learning model takes inputs and spits out some kind of output. So a single API works with whatever model you throw at it. And you can choose whether to host these models, bundle them with your app as part of your APK. You can put them on your own server, or you can have Firebase host them. So if you want to build, if this is the route you want to go down to build a custom model, how do we do it? There's a couple steps. And the first step, which I just alluded to, is getting a model. So the details of this are actually out of the scope of this talk. I just started in data scientist. I'm not an expert by any means. So the fast way to get started is to find an existing model. And I think TensorFlow Hub is a repository of reusable models that the TensorFlow team runs. Or you can retrain an existing model. And that's what I did to build the dumpling detector. That's actually a powerful technique of machine learning in that you can speed up generation of a model by taking an existing one and kind of lopping off the last layer that does that classification and replacing it with your own types. So you have a model that knows how to recognize shapes of objects in the world. It was trained to recognize an apple, a car, a telephone, a keyboard. But then you just teach it to recognize other things like dumplings. But all the learnings about finding shapes and colors and patterns, you don't have to retrain to teach it that. And the last one, this is the hardest one, is to get somebody else to write you your custom ML model. Google has a lot of documentation about how to use TensorFlow to build these models. So if you're really eager, you can kind of go down that route yourself too. Second thing you do is to convert it into the TensorFlow Lite format. ML Kit only works with TensorFlow Lite, so any models that you see on the web or in demos that use TensorFlow need to be converted to the TensorFlow Lite format. Fortunately, the TensorFlow distribution comes with, it used to be called TOCO, which is a good way to remember it, TensorFlow Optimizing Converter. It's called something else now, I think TF Lite Convert. This will just take as input your original TensorFlow graph and then spit out in TensorFlow Lite format. That's sort of the best case scenario, is that you just run this one command and it does it. In practice, there's a lot of things that the TensorFlow Lite interpreter doesn't do. They're known as operators, just kind of like mathematical operators. Different machine learning models use different operators, and not all of the things that are supported in the full TensorFlow are available in light. So during the conversion process, you will actually get an error that says this operator is missing. So at that point, you either have to go back and change the model, or ask the person who made the model to change it. Or the other option, and this is tricky too, is to go back to the original way of doing it is like building the TensorFlow Lite interpreter from scratch and just replacing the one that comes with ML Kit. Now you have a custom one that includes those operators. So remember Google, when they developed TensorFlow Lite, intentionally kept it a small set of operators so that it would work well on phones today and would work with the existing use cases. But you can rebuild the TensorFlow interpreter to include your operators. So this is something I haven't tried before. I'm perfectly happy playing around with image classification apps for now. But if you want to do something like recurrent neural networks, where you can recognize as you're typing characters, predict the next character, or like you've probably seen examples where people take all of Shakespeare's plays and they generate these new plays, or recipes, or song titles, or things like that. So that kind of task you can't do with the TensorFlow Lite as it is right now. OK, so the next is getting that model into your app. This is fairly straightforward. If you just want to bundle it locally, so build it as part of your APK, just drop it right in the assets folder. The important thing here is to include this little paragraph to make sure that the compilation tools don't compress these model files. Now, the reason is, normally you want your APK to be as small as possible, but these files need to be kept uncompressed because they're memory mapped direct from the APK right into memory so that your app can load really quickly without a whole stage of decompressing it. The last bullet there, I just note that you can also download this from your own server. So if you don't trust Firebase hosting, you can use the ML Kit SDK, but also tell it that I got this. I'm putting the model in my own server. If you decide to go with Firebase, this is just a series of screenshots to show you how to add that model into Firebase. So set up a Firebase project. You'll see an entry on the left called ML Kit. Navigate there. Click on the Custom tab. Click on the Add Custom Model button. Give it a name. This name, don't just call it temp or whatever. It's something that you're going to need in the SDK later. So make sure it's descriptive enough. Then it'll give you a dialog to upload your model. And when it's uploaded and published, you'll just see it in a box like that. It's a super bare bones interface, very basic. And the only things you can do here are replace that model with a new one, download it, the original file, and then delete it. So if you want to train a new model and replace the existing one, that's when you would use replace, and that automatically gets sent to your app. The last step is to integrate the SDK into your app. Now, this is just one numbered item here, but there's actually a bunch of sub-steps involved with that. So I'm going to dig into a little bit more here and point out some things that you should be aware of. The first thing is to just bring in the dependency. This is, if you've used any other of the Firebase SDKs, this is exactly what you would do for Crashlytics or remote config or anything like that. If you've never used Firebase before, I'm just going to plug a talk after lunch today by Sweetie, which walks you through how to get Firebase into your app. So go check that out if you're interested in Firebase in general. Next, we have to define what the sources are. So remember, your models could come from a file that's bundled with your app, downloaded from your own server, or hosted on Firebase. So if it's one that you want to bundle, you create it using this builder. You pass it just a name that you're going to reference later. And then you just tell the builder where it is under assets. Similarly, if you wanted to host the model on your own server, you would write the code to download that from your own server. And then wherever you wrote that, under /SD card or wherever it is, you would call set file path with the absolute path to that. Now, if you were using a Firebase hosted model, you have a little bit more flexibility. And also, sorry, not just flexibility, but you have the convenience of being able to tell Firebase when you should download that model from when you upload it to the cloud. in that console there. So you have to define these download conditions. So the download conditions allow you to, without having to write any extra code yourself, say like only download this when you're on Wi-Fi, or only download this when the device is idle or when it's charging. So that allows you to just, with one line, sort of change the policy in which it uses to download the model. 2 of those are only available on Android 7. OK, so now we haven't actually defined the cloud model source like we did for the local model source. So you have to, those conditions that you defined on the previous slide, now you have to bind it with the thing that defines your cloud source. Remember, we gave it a label, my custom model on the Firebase console. That's what you reference here, so that it knows that this cloud model source object is associated with that model you loaded into the console. There's one option on the builder here called enable model updates. This allows you to download the model on the first time that the user installs your app, but not get any subsequent updates. So you have the flexibility to set that if you want. And then it also distinguishes between that initial download and subsequent updates. So perhaps your app is completely useless without the machine learning component, and so you need to force that initial download regardless of the user's connection. But perhaps it's not crucial that they get the subsequent updates. So you can kind of control with these setters when to download those models. All right, we've defined the sources. Now we're almost ready to define the interpreter, the thing that actually runs the model. You need to tell it via this options object which of the cloud models, because you could have multiple ones uploaded in the console, and which of the local ones that you want. So you do this by just saying set cloud model or set local model. You don't have to have both of these. It's fine to just have one and not the other. So for development, you might not want to go through all that trouble of putting it up into the Firebase console. You can just execute with a local model. So just omit the set cloud model one. And conversely, if you don't want to bundle anything, you want to keep your APK as small as possible, you just say set cloud. If you say both, then the cloud one has a higher priority. And only if you can't download that model from the cloud for whatever reason will it fall back to the local one. So it's up to you. It's like it's a time, space, battery kind of trade-off. So is it more important that your user gets the app, it has a great first experience when they first launch it, or is it more important to get the well-trained model from the cloud first? OK, so we defined the interpreter. We've defined the sources. The last step, I put a little emoji here because this is a very important step. It's key, defining the model inputs and output shapes. So in machine learning, your models are a series of, you can kind of visualize them as a series of nodes that take inputs and spit out outputs. Your input, in this case, the image that we're trying to classify, goes as input into one of these nodes. But from just getting a TF-Lite file, you have no idea what that input is. There's no metadata that tells you that this is the input node. So you need to know which node it is. So you can either ask whoever gave you the model, whoever designed it. If that's not an option, there are tools, TensorBoard, which is a training visualizer, a real-time training visualizer that comes with TensorFlow is one way. There's another open source tool called Netron, which dumps out a graph that it interprets from your model file. The output doesn't tell you what is the input, but at least it visualizes. And you can kind of see, OK, all these arrows are pointing down to the bottom, and this is the one at the top that is probably the input. OK, so once you identify the input, you need to know what the shapes of the data are. And this is an example of how you would specify the shape for image classification. So this is exactly the code I use for this dumpling detector, this not Hagao thing. You look at the input there. If we parse out that set input format line, the 0 there just means that this is the first input. It only takes one input, a single image. And then that empty array definition at the end, it has 4 dimensions there. So the first one is saying that this input takes a single image. The next two, the 224s, are saying that this is a square image of 224 pixels on a side. And the last one is saying that for each of these pixels, I have 3 values corresponding to the R, G, and B levels, the 3 color planes or channels. The output is similar. There's a single output. And that single output has a single image. That's the first one at the end. And 1,000 refers to the different classes. So actually, this is not exactly the one I use for my dim sum, because mine only detects maybe 8 kinds of dumplings right now. This is from the original MobileNet classification. So the number of classifications are the types of things that you've trained it on. So if you train it on pictures of cats, dogs, apples, and water bottles, that's 4 classes. And your output will be an array of 4 items. The things in the array are going to be the probabilities. So the likelihood that that image is a cat. And the way that these algorithms work, those probabilities all sum up to 1. OK, that was a lot of information. Actually turning your image, because these algorithms don't take JPEGs, they don't take PNGs, they don't take Android bitmaps. They take raw arrays of pixels. You can look at sample code for how to do this, but you need to get it into a format that is understandable in TensorFlow. So in this case, we just allocate the array of the right shape that we want. The comment in there is a bunch of code. It's fairly straightforward. The bitmap, if you have a bitmap in Android, it has APIs to get you the RGB values in the pixel. If you're not using a byte-oriented model, so the models, TensorFlow models can operate on byte data or they can operate on floats. You may have to normalize. So instead of RGB values being from 0 to 255, if they're floats, they have to be a floating point number between 0 and 1.0. So you might have to take all your RGB values and divide by the median or mean. This is getting a bit outside of the scope of this talk, but there is sample code that can show you one way to do that. Then you have to wrap that in a Firebase model input object, add all your inputs, however many that your model needs. Now we're finally here. We're able to run the inference. We have the interpreter. We have the input-output options, and we've wrapped the input. So you just call interpreter.run, and you get back a task object. If you used Firebase before, you recognize the task object as the class from the Play Services API. Just represents an asynchronous computation. We add a listener so we know when it's done, because this is going to run in the background. And the onSuccess method, we're passed the result. So inside that result is going to be all of the outputs. Remember, this is a general API that could be used for any kind of machine learning model, so there could be more than one output. In our case, it's just a single output, and the output was 1 by 1,000. So here's the incantation to get that probability array. And what do we do with that? Well, it depends on what your app is doing. In this case, we probably want to iterate through that array and pick the one with the highest probability, match it up to the set of labels that we trained on, and then we can just display that to the user and say, this is a dog, this is a cat. OK, so that's sort of the end of the code-heavy slides. Some things that I wanted to highlight next are some problems you may run into, and also what you can look forward to. So first, about TensorFlow Lite. To say that it's a very active project is a bit of an understatement. On GitHub, it has 110,000 stars, 60,000 some odd forks, and over 10,000 closed issues. And the sheer amount of information in that is just really overwhelming, because a lot of answers about why stuff isn't working comes up when people ask questions. Because the project is so popular, a lot of people ask the same questions. Different people answer at different times. It's the same with any sort of popular open source project. So there's a lot to dig through when you get stuck. Because it's also moving really fast, the TensorFlow team hasn't had time to fix a lot of the documentation. If you run into these broken links, there's always a way to report them. I highly encourage you to do that to help your next fellow developer. And same with the code labs, too. The code labs have already gotten out of date with the latest releases of TensorFlow. So if you don't follow their instructions and you download a newer version, then you might have to adjust some of the commands to get it to work. I talked at length about getting the input and output shapes. Double, triple check this when you're making your own apps, because there's nothing worse than you build the whole app, you think you got it right, and then you click, and you just get an exception. Or worse, you get nothing. I ran into this not with the shapes, but with floating point versus bytes. So I didn't know that the model, like the type of the output, I didn't know about those tools to visualize what the graph was. And so I spent a long time trying to figure out why I wasn't getting any results at all. Coming up, I mentioned this briefly, as the neural network API develops, as the devices get more powerful, as the team has time, they're going to add more operators into the base TensorFlow Lite implementation so you can do more kinds of machine learning tasks. And they've also stated they want to allow people to do on-device training. So far, everything I've talked about, the example I built, you train the device, you train the model offline on your own laptop, in the cloud, because that step can take a long time. You might have 10,000 images that you're pushing through the model, and you do 4,000 iterations. So it might take 5 minutes on a desktop, 5 minutes on a GPU, could be hours. For some of the most complicated models, if you're doing it from scratch, it could take days, even on a GPU. I'm not sure what the on-device training will look like, because it's probably not practical to do 10,000 images on a device, but perhaps it's some sort of cloud source model where that people can submit images that didn't get classified accurately and help retrain it by labeling it correctly themselves. So who knows what that might look like, but that's something that the TensorFlow team has announced. With ML Kit, you notice when we were looking at the screenshots of the console that the only thing you could upload was your model. But for an image classification task, you also need the labels, right? So it outputs that array of probabilities, 1,000 things. It's just literally a bare array with 1,000 floating point numbers in it. What does that correspond to? Which one is cat, which one is dog? You need a label file associated with it. But there's no way to store that in ML Kit. And also, if you want to do experimentation, there's no way to keep a history of the versions or to say, like, I want this version. The only way to do that now is to upload multiple models with different names and then use a framework like remote config to pick between the two at runtime. That SDK also leaves something to be desired when you're using the cloud-hosted model, in that you can't find out when the model got updated, nor can you query anything about it. So maybe your user reports a bug, and you're like, oh, no, I fixed that. I improved the accuracy by 10%. Why am I still getting poor accuracy? It would be nice to know that you can query at runtime which model version you're running, but you can't do that. So I've raised these things with a Firebase product manager on Slack, and they filed a feature request, so who knows when this might get resolved. One thing that they have announced and is available in beta now, if you sign up for it, is being able to do model optimization and compression. So that allows you to keep your local models really small and run faster. And that'll be part of the ML Kit console. And I mentioned before, too, that the domains of the types of things that you can use with ML Kit is going to increase over time. The speech one is interesting because now you can do something like wake word detection. So if you have a Google Home or an Alexa, it's listening all the time with a small machine learning model that only recognizes, hey, Google, or Alexa. You can build that kind of functionality into your own apps if you have wake word detection. So you'll need the capability to do speech recognition, which isn't available that I know of with TensorFlow Lite right now. OK, so after all this, should you use an ML Kit custom model? Well, it depends. If you have an existing TensorFlow Lite model already, you're off to the races. You're way past the hard part. So yes, maybe. If you're able to take a regular TensorFlow model into TensorFlow Lite without any errors, and you can figure out the input and output shapes, sure, ML Kit custom models might be for you. If you like the idea of offloading, hosting the model to someone else, ML Kit could be a good fit. Or if you just want to play around right now with something beyond sort of the stock examples, it's really easy to get started with ML Kit. All right, so you've heard me talk about ML Kit custom models, TensorFlow Lite, and you are interested in learning more. I have a whole series of articles, code labs, and stuff that I found useful. If you're the kind of person that likes to get hands-on, the very first code lab you should start with is the Google one called Custom ML Models with ML Kit, very imaginatively named. The problem with this one is that unlike the TensorFlow Lite code lab, this one bundles a picture of a mountain and a picture of a flower in the app, and that's all it lets you do. Like, you build the app, you pick the mountain picture, you click predict, and it says mountain. And you switch to the flower picture, and you click predict, and it says flower. So it's really not an exciting demo app. Whereas if you use the TensorFlow Lite code lab, you get a live camera like you saw me do, and you can walk around your house, outside, on your campus, whatever. You can see, like, oh, person, car, whatever. There's like 1,000 things it can recognize. So what I've done, I'm in the progress of doing, is adapting that code lab with the camera to use ML Kit. So you get sort of the best of both worlds. It's kind of working. You can only run the app once. Like, every time you resume, it freezes, so I have to fix that. But anyway, you can see like the process of doing that. Somebody else, Harshit Dwivedi, has made a Pokemon detector. So instead of recognizing dumplings, his recognizes Pokemon. So he's got a repo with that. And if you're interested in retraining image classification models, the TensorFlow tutorial called Image Retraining, I've linked it there, it has way more detail than just the TensorFlow for Poets code labs. This one talks a lot about the retraining script, how to divide your images into training and testing splits, data augmentation. So that's the idea where you might have a small set of images. Like, the more training images you have, the better your models will perform in general. So augmentation is like taking the image and automatically generating the mirror image of it. So this works for a picture of an animal or something, obviously not for text, or adding some blur to it, or changing the exposure of it, or cropping it. And so automatically doing all that to sort of quickly augment the size of data you have to train with. If you like reading articles, if you're a visual learner, there's a series of good blog posts. You probably recognize a lot of these names. They're GDEs, many of them, and they are prominent bloggers. So Mark Allison of Styling Android just had a 3-part series about his experience trying to build handwritten digit recognition app. So imagine you're building an app that can read what people fill in on a check, if anybody knows what a check is, or something where you have to write handwritten digits. So some of his experiences doing that. Britt Barak just wrapped up a 7-part series that is like sort of a survey of machine learning in general. Like, what are neural networks? Why do you want to run ML on devices, all the way up to using ML Kit. And a bunch of other ones that are also related to ML Kit, I've listed there also. There's that ebook that I was mentioning, written by Pete Warden, who wrote the original TensorFlow for Poets code labs. And a lot of the text in this book is actually repeated verbatim in the TensorFlow documentation. It doesn't cover TensorFlow Lite nor ML Kit, but it's still a pretty good background in one book. If you get really stuck, a couple places you can go to for help. There's a Firebase community Slack. There's, 5,000 or more people on there, including a bunch of developer advocates from Firebase and Google that hang out there. You can't expect to get individual help, but like with any sort of community Slack, there might be somebody out there that has the same problem you do. Stack Overflow has 2 tags that might be helpful, TensorFlow Lite and Firebase ML Kit. And I mentioned before, like with 12,000 closed issue and another couple thousand open ones, that could be a place to get help too, but be prepared to spend a lot of time searching. That's it. That is how you can reach me. I prefer email or Twitter. Come talk to me if you want to know more about Shopify. We're hiring in Android and data. If you want to talk about Canada. I have stickers too if you're trying to grow your laptop collection. And also, if you're hungry, please help yourself to the dim sum. I kept it in the fridge overnight. It should be good to eat. And I will have slides. I'll send out a tweet when the slides are ready. Okay, thanks for listening.